Okay, we're going to be talking now about some applications of integrals, and we're building up to something greater. We're talking about areas, but we're building up to something about volumes, but that's not in this video. What we're going to do first is we're going to learn how to find areas between curves. So let's assume we have two functions, f and g, and they're continuous. And let's also assume that f of x is greater than or equal to g of x. Okay, so then the area between the two curves is simply the difference, if you integrate the difference rather. Okay, so now what if the case is that g is greater than f? Well, then you'd say g of x minus f of x, okay? And we're going to see that in the very first example, that we've got to look at the picture that's there in a couple of different ways. So what we're going to do is we're going to look at this example that I'm giving you, and it says find the area of the shaded region. Now what we've got here is a problem that shows a figure, and there it is. Zoom out a little bit. We've got this figure, and we should see that we're going to find the area between the two curves, but it's important to note what it is that you're looking at. The first thing to note is that g of x is this line here, and f of x is this curve here. So in this instance, on the left side of 0, we know that f of x is greater than or equal to g of x. But on the right side, we know actually the reverse is true, that g of x is greater than or equal to f of x. So we've got to integrate this in two pieces. Okay, we've got to look at two sides of the coin here, if you will. And so what we're going to do is we're going to make note of the intersection points. And we see here there's an intersection at -4, at 0, and at 3. So we're going to integrate first from -4 to 0, and then from 0 to 3, and then we're going to combine those areas. So let's go ahead and make use of this area formula that we just found out, and we're going to take a look at this. Okay, so first thing I'm going to do is say, okay, well, I'm going to examine this from -4 to 0, and in this instance, I have f greater than g, so I'm going to say f of x minus g of x, okay? And I'm going to integrate that with respect to x. And then I'm going to add the integral, in this case from 0 to 3, because that's the next intersection. And looking at this side of the graph, g of x is greater than f of x. So I'm going to say g of x minus f of x. And then again with respect to x. And so now I'm going to look at these from the perspective of the function and do a little bit of algebra before I actually integrate. So let's go ahead and substitute the values that we know for f and g. So that is to say that f was x cubed plus x squared minus 6x minus, and in this case g of x is 6x, so let's just write minus 6x, and then of course dx. All right, we've got that right there. And now we're going to add the second integral from 0 to 3. And in this case, it's going to be 6x minus, so I'm just going to take the opposite sign of all of f, just to make it easier here. Minus x cubed minus x squared, and then plus 6x, because that's the opposite sign. And then again with respect to x. Now, once again, we combine like terms. So we're going to go ahead and do that, make it a little bit easier on ourselves. X cubed plus x squared minus 12x dx plus the integral from 0 to 3. And then I'm going to combine like terms again here. I end up with something like 12x and then minus x cubed minus x squared, and then again with respect to x. And so now I think I'm ready to take the antiderivative of all of this stuff, and so I'm going to write that out down here at the bottom actually. So I'm going to move this up just a little bit, slide it up. Okay, so what do I have here when I take the antiderivative? I have x to the 4th, I have divided by 4, plus x cubed divided by 3, minus 12, in this case x squared, divided by 2, evaluated from -4 to 0. And then I'm going to add, let's see here, 12x squared divided by 2 minus x cubed, I'm sorry, not x cubed, x to the fourth divided by 4 minus x cubed, here's the x cubed, divided by 3. And then again, this one is evaluated from 0 to 3. Well, these are rather nice. I mean, you can simplify them just a little bit more. And I guess I could do that for you. Let's go ahead and do that. What do we get? X to the fourth over 4 plus x cubed over 3 minus 6x squared. Again, evaluated from -4 to 0 plus, and then it's 6x squared minus x to the fourth over 4 minus x cubed over 3, again evaluated from 0 to 3. We've got that right there. And now we're ready to plug in. Well, when we plug in 0 in the first case here, we just get 0. So we have 0 minus, and then I'll put parenthesis here, I have -4 to the fourth power divided by 4 plus -4 to the third power divided by 3 minus 6 times the -4 square, okay, plus, and then again, in this case, it's 6 times 3 square minus a 3 to the fourth power divided by 4 minus 3 to the third power divided by 3, and then minus 0 because all of those have an x in them, so they all evaluate to 0. So we really don't need the zeros there, but in the first case we do, because we need to show the subtraction and the fact that we're taking the opposite sign of everything. Okay, so I'm just going to go ahead and simplify everything here for you. We get a negative, in this case, 256 divided by 4 plus a -64 over 3 minus 96 plus we've got what is that, 54 minus 81 over 4 minus 27 over 3. Combine all that good stuff. All right, this right here gives me a negative, and I believe it's negative 160 over 3, so that makes for positive, right? And then this combination over here is 99 over 4. And so we add those two, 160 over 3 plus 99 over 4. You can do that. I'll leave you to the trivial math there. And then you get something like this, 937 over 12. Okay, so not much to it here. Not much to it at all. Just some I think it's just more tedious in doing the calculations, really, but that's how that represents there the area between the two curves. So let's go ahead. I'm gonna show you another problem here, and you might like this one. So let's take a look at the next problem. Okay, in this problem we've got one function above the other, and that is, let's say that this one right here, I know it says y, but let's give it a name. Let's call this one f. Let's call this one g. And g is actually represented by the line up here on the top, and f represented by this parabola that's on the bottom. So in this case, our area function, and I'll write that out, it's going to be the integral from a to b, in this case of g of x minus f of x, okay? So that's perfectly okay. You've got to figure out which function is greater than the other, and that's how you go about doing this, okay? So in this case, it's really nice. We just have to figure out what are these intersection points there, okay? But graphically, you should be able to see them, okay? So graphically, this point right here is 1, 0, and this one right here happens to be 4, 3. Okay, so if you don't readily see them on a problem you're working on, you might use your calculator to find the intersection, and that's how you can set up and figure out what the limits of integration are. So let's go ahead and take a look at the integral, and thankfully in this one it's just one integral that we have to worry about. So we're going to integrate in this case from 1 to 4, and we're going to take our g of x, which in this case is x minus 1, and we are going to subtract, in this case, the f of x, which is x squared minus 4x plus 3, and then with respect to x. So it looks something like that. Okay, so now what we do is we set this up so that we can, of course, distribute that negative sign, and then so that we can combine like terms. So x minus 1 minus x squared plus, in this case, 4x, and then minus 3, and then dx. And now I think we'll combine like terms. Yep, that's what we're going to do. So let's just put it in descending order just so it's nice. Negative x squared, the x plus the 4x gives me a 5x, so plus 5x. And then negative 1 minus 3 gives me a negative 4. And now, again, with respect to x. So now I'm ready to take the antiderivative. So I end up with something like negative x cubed over 3 plus 5x squared over 2 minus 4x, and then evaluated from 1 to 4. And so this is pretty nice, nothing really to clean up. We're ready to plug in. So let's see what this looks like. I'll put a bracket here. We have a negative, and I'm going to put 4 cubed over 3 plus 5 times 4 squared over 2 minus 4 times 4. And then I can plug in the 1, so subtract, and then the difference evaluated at 1. Negative of 1 cubed over 3 plus 5 times 1 squared over 2 minus 4 times 1. All right. Okay, so leave me to the easy part here. I'll just write it out for you. That's negative 64 over 3 plus 80 over 2, which is just 40, as you'll see, minus 16 minus, and then we look at the next part, it's a negative 1/3 plus 5 halves minus 4. Okay, and we've got that stuff. I'm going to combine the like terms here. Well, they're all like terms, but I'm going to work on the operations here for you. 8/3 minus, and this one becomes a negative 11 over 6, which is a plus. So you do that. Again, it's not terribly difficult. This is probably the hardest part, not the calculus, I'd argue. 9 over 2. And so that is the area between that parabola and the line, 9 over 2. Again, so some really nice examples about finding areas between two curves. We're really fortunate that we were given a graph. In the next video, we're not going to be as lucky, but I'm going to provide the graph anyway. My advice is, if you're not given the graph, graph them, figure out the intersections, visualize them. It makes it so much easier to handle and to compute. So, as always, I hope this video was helpful. And remember, like and subscribe.